Hello and good afternoon. I hope you all can hear me. So I am Ella, and I am happy to take over the first 10 minutes of this presentation. And later on, my colleague Thomas will also share his thoughts. And what we will speak about today is basically our Furhat experience, very hands-on, but within our context of children's relationships and information searches that we are interested in within our project. To quickly introduce our project, we have a project called Chatters, which stands for Children and AI, Talking, Trust, and Responsible Spoken Search. We do this together with Vanessa Evers, Theo Huibers, Kiet Trong, and Roland Ordelman. And we are sponsored by SIDN, ClickCanal, and the Institute of Sound and Vision. We are from the University of Twente in the Netherlands. And if you want to know more about this project, you can always hit us up. But like I said, this will be very hands-on. So we will be sharing both the back end and the front end of what we programmed Furhat to be. And we take a quick look at the results of our experiments. So what we first wanted to do is we built an experiment to see how do children trust a robot and what do they do with the information that the robot provides. This was done during COVID, so this meant that we had to do it remotely. And since it was with children, we also needed to do it wizardly because the speech recognition is simply not good enough yet for Dutch children to be understood. So to give a quick overview what this experiment was for, we wanted to gather speech to see whether children's speech can reflect the trust that they have in the robot. And we wanted to see whether they follow the suggestions from the robot based on how much they trust the robot. And furthermore, we also did an interview with the children to gather broader opinions on what robots are and what online information is good and what is not good. The experiment meant that it was a quiz where the children asked the robot a question. For example, what is the name of the bird from Twitter? And then the robot first asked the child, oh, do you have an idea? And then it would come with an answer suggestion, such as, I've read on the internet that it's Harry. And then the child could respond to that. Now, I give you 3 seconds to think about the right answer. Is it Harry or is it something else? It is something else. The bird from Twitter is called Larry. Within our experiment, we wanted to see if we can manipulate trust in such a way that we have a very low trust of children in the robot and a very high trust. And so we basically made 2 personalities of the Furhat. One was named Bart and one was named Hank. Bart was the trustworthy one and Hank was the untrustworthy one. About the setup, I said it was very complex, and I think you will soon agree with me. So we had 3 sites. First, we had the child that sat in their school in a private room where they wouldn't be disturbed. They had a laptop there and a microphone to record the speech, and we had remote access to that laptop. Then I was here in my work office with the robot. I could reposition the robots if necessary. I could change their heads. But furthermore, for the rest, I was just the researcher that children could talk to via Zoom. I introduced it, I debriefed the children, etc. I did the interview with them. But then we also needed a wizard. So we also had a wizard, that was Thomas actually. He was, due to circumstances, all the way in Sweden, where Furhat is from, so that was quite a coincidence. And so he remotely even wizarded the robot. This was done via VPN and stuff. And the robot has, of course, a virtual version. So we could have just used the virtual version, screen shared, and done that via Zoom. But we believe that putting a robot in front of a camera makes it more of a physical embodiment within an actual space. Like we are talking right now, you also think, oh, I am not an avatar. I am somewhere in a space. that would also be for the robot. So we put a camera in front of the robot and gave it its own Zoom account, and then the child could talk with the robot via Zoom. The child would then have both the Zoom account on one split of the screen, and on the other side of the screen, it would have the form with the quiz and the questionnaires that we were interested in, such as trust and likability and intelligence of the robot. So it's a very complex setup. We have 3 sites and they're all interacting with us. Eventually, it actually worked quite well. So although it's complex, I think people could really use it in the future as well. If worse comes to worse, there might be another pandemic, we can just use it again, or maybe also for other purposes. And then about the wizarding. The wizarding, it quickly becomes very cluttered. And so what we thought of was something that we would like to call a state-aware wizarding. This means that whenever you enter a certain state of the interaction, you move on in the wizarding interface, and so you don't have all the buttons all at the same time. There are some buttons that we kept all the time, so those are the idle buttons that you see here. But on the bottom left, those buttons, the 8 buttons that you see there, those are state related. This means that when the wizard says start quiz, you go to the next state and the buttons differ. This reduces the cognitive load for the wizard. So I promised some code and how it looked in the back end and in the front end. So if we have a trustworthy robot, we programmed it to be a little bit more verbose, to show more gestures, be more expressive, and also be a bit more optimistic, because children really respond to this. So you can see in the code, there are more positive reactions, both in the words that it uses and in the gestures that you can see it here.
Cool. What do you think robots like me are capable of?
I'm sorry if it's cool. I try to get the volume a bit okay, but it's quite hard. Then if you have the untrustworthy condition, then it's not that verbose and it doesn't really express much.
What do you think robots like me are capable of?
So this is a very small example. A bigger example here is when the robot asks, do you have any experience with robots at all? And you see in the trustworthy condition, it's very verbose, it has a lot of gestures, and in the untrustworthy condition in the bottom, there is only one thoughtful gesture, and it's fairly straightforward in what it says. And there's this flicker. This is what we added to also manipulate the capability of the robot a bit. It's a mixture of textures and delays. And so you will see that it looks like it gets an error and it really doesn't know what it's doing. So first,
I've been waiting to talk to someone. I've talked to a lot of people. You haven't met before. Have you talked to a robot before?
And untrustworthy one.
I don't know you. Have you talked to a robot before?
Oh, good. What we found was that Bart was indeed trusted more by children, but also found more intelligent and likable. So those might be related to when we manipulate trust for children. Now I would like to give the floor to Thomas so that he can talk more about how Furhat searches with children.
Yes, thank you, Ella. And also thank you to the people at Furhat for having us. I have been a little bit sick, so let's hope that my voice will last until the end of the meeting. I will talk a little bit about my research in the same project as Ella. 1 second. Yeah. And I focus more on the information search part, so how children can search with the robot. I'll first talk a bit about the background of this research, and then I will show some of the Furhat features that I've used that may be interesting to others. So what I'm interested in is using a robot to search for information for kids. And of course, this is already possible through commercial voice agents such as Alexa or Google Assistant. And there are some advantages to this, like children don't have to spell and type, which is very complex for them or can be a hindrance for them. It's more collaborative. The system can use multiple signals to engage with the child. And if we use a robot, it will also draw attention in a museum setting, which is one of our use cases. However, these commercial voice assistants often use an interaction style that just consists of one statement, and then it tries to find an answer and gives the best answer that it could come up with without actually having a conversation. So this style of interaction we can call one-shot queries or question-answer interaction. And it means that kids cannot ask follow-up questions like they assume, and they have to include a lot of context into one statement, which is quite hard for them. And they don't get assisted with suggestions or clarifying questions. So I think we can better support children in searching by using spoken conversational search, which is also called conversational information seeking sometimes. And I want to explore a first simple implementation of this with children. And in this implementation, we can use multiple turns. So the system builds up an understanding of what the child is looking for over multiple conversational turns. Excuse me, and it will use elicitation questions to try to get the child to speak more about their information needs. Next slide. Yes, thank you. So the conversation that we have in mind is as follows. There's an introduction talk in which the robot introduces itself, asks the child a few questions, and then the child can pose their initial search question. Then the robot will ask, the robot will enter this loop in which it asks elicitation questions and tries to get more keywords of what the child is looking for from the child's answer, and then until a certain threshold, and then it moves on to result presentation. So the main thing with this background is that I try to get more conversation into the search process. And now we'll go on to the second part, which is that I will show some of the Furhat features that I use in building this robot, and hopefully they're useful to some of you as well. So there's the setup in the next slide, which will be using a museum archive of one of our project partners, the Institute for Sound and Vision. And they have an archive of lots of open access media, as well as a collection of Dutch public broadcasting media, so state-funded media. And most of it's, or what we're interested mostly, is video. And then there's the Furhat and a screen on which the results can be displayed, so the videos can be displayed. And so the main communication between these components is that the Furhat will gather these keywords through conversation. Then it will send a query to the archive and get results back. And if necessary, the Furhat will send a link to the results to the screen so that the screen can fetch the resulting video and display it for the child. So for this, we are querying the museum API. So we gather the keywords, then these keywords are put into a formatted query, which is a JSON file. And this gets sent to the API, and we get a result list back with some metadata. So there's a title of the results, a description, a link to the videos, and some other metadata like the relevance of the search. And querying an API like this can be done quite easily, which is also explained in the documentation that you can see linked below. To get this result is basically that one line using the KHTTP library, in which you need, well, the URL of the API and then the formatted query, which in a format that the API expects. And during development, I've also been trying the archive.org API, for example, in which you can also use, you can just see in the browser the URL that you're using, and then you can use that also in the Furhat. This slide can be skipped, sorry. Then we also have a graphical user interface on which videos can be displayed. And for that, we're also using the Furhat SDK. So there's a couple of different ways you can build a GUI or graphical user interface with Furhat. And we're editing, or we're customizing the hosted custom GUI. And so it's just a screen with the video that gets sent from the Furhat to the GUI. So once you build this GUI, it's just a Node.js app that you can open from something like a tablet that's next to the robot. Yeah, again, more information can be found on the Furhat documentation as well. So most of what I've described now is I'm kind of finalizing it. So I'm building it and finalizing it, but I also ran a pilot study at the After School Center with a simpler version of this robot that used pre-programmed search results instead of querying the API. For this, I also needed to implement this kind of question answer condition, so something that I could compare it to that works more like a Google Home. There were some things that I wanted to show in regards of that, but I think for time we just have to skip to the next slide. So I had some initial pilot there at the after school care with 11 kids talking to the robot and finding these pre-programmed search results. And I had a few measurements. This stuff will also be published open access in a workshop proceedings quite soon. But the gist of it is that most kids seem to prefer this conversational approach over the traditional approach. And I also describe some more about how I want to, what I want to measure in the full-scale study. Yeah, so I hope that we've given you a nice overview of our research and inspired you with some of the Furhat features that we used in our research. So thank you for listening.